I'm just scrolling down a little bit so we can see the rest of the code. So that's basically it. The implementation of an HTTP server. This is obviously very simple. Most HTTP servers do different things depending on the kind of requests they get. They will parse the actual header and figure out what resource a particular request is looking for, and maybe you want to do something different depending on what's being requested. That's a lot of the ways that you have dynamic web content. And a lot of times we want to do something different because of the request method. So in our examples, we're going to use get, and we can take a look at get, since that's what our browser does. Our browser mainly does gets when we type in the URL of a particular web server. But there's also post requests and update requests, delete requests. There's a lot of different kinds of requests you can make to an HTTP server if you're doing a full implementation of the HTTP protocol. This is just basically a server that responds with the appropriate HTTP headers for the response and a status code. But there's a lot more that you can do in a full-featured HTTP server. But this is basically how you would start developing the building blocks for that server. It works off top of TCP sockets, and it's basically really similar to running a server in TCP. The only thing that changes is the data that gets sent back and forth. So we can actually go ahead and open a web browser after this is done, and we should be able to, well, first let's write some sample HTML to test this with, and we need that index.html file that we refer to up here. Once we write that file, we'll put some test data in there, and then make sure it gets served, and we'll open it in the browser. So before we get going, just two quick corrections. We're missing a semicolon on this line, and there's also one additional header that we have been including for the other server socket applications that wasn't included here, and that's the net in.h. So make sure you include that. So now this code should compile properly. We're not going to put too much complicated HTML in here, just some text that we can make sure gets rendered appropriately in our web browser. We're not going to go over the HTML specifics for this class. You can basically copy the tags exactly as you see here. We're not going to go into too much detail about what's what. We'll just have an HTML and body tag. And that's really all you need. So now we're going to go ahead and make the executable. Make sure everything compiles properly, and then we can run the server and access it from our browser. So I've opened a web browser and navigated to localhost, since that's basically the same as that's a local IP that's bound to our machine. It's an interface that we can access, and navigated to the port number, and as you can see, the HTML that our web server is serving gets shown to the screen. So if we go ahead and change that HTML and reload the page, the appropriate thing will also get served. So as you can see, when I hit refresh, our server is actually serving the content from that file. It's loading it from our file system, and since it's in a string, we're rendering it out to the browser. This is basically all you need for a basic, simple HTTP server that doesn't implement a lot of special dynamic web logic. So now that we've implemented a basic HTTP server, we're going to take a look at what happens with sockets on the other side. What sockets need to do in order to request data from an HTTP server. So we're going to start building an HTTP client. And it's going to have a lot of similarities to the TCP client, but again, the data that gets sent back and forth is going to differentiate. There's also a couple more operations this time, as opposed to just sending or just receiving data. We're going to need to do both, since in HTTP, a client makes a request for data and gets a response, and the response is basically the information. So let's go ahead and get started with our HTTP client. So again, most of the same libraries. Then once again, socket and types. So we include the rest of the regular socket headers, socket and types. And then there's one additional header we need to include this time. The include looks like this. It's ARPA/inet.h. That's INET. And this additional header contains a function for converting network addresses. And since this program is going to be a little bit versatile, we're going to need to, in the same way that we need to convert our port number integers with a function, we also need to convert our IP address formats to something that our structures can actually work with. So a function from this header is going to be able to do that for us. After these includes, we can write our main function again, but we're going to add the parameters to it this time. Main is going to take an argument count and a list of arguments this time. And this is basically the number of command line arguments that we pass in, and the argv list is a list containing all of the actual command line arguments. And the 0 index element of this list, I believe, is the actual name of the program. So we're going to want element 1 if we want the first command line argument passed to this program. Since this is a TCP client, we're going to use the command line argument to specify what server we're going to be connecting to. So to start, we're going to grab the address of the server from the command line arguments and store it in a pointer. This is basically all we need to do. We create an address character pointer, and we store the first command line argument in that pointer, in the character, rather. And then we continue on by writing a regular TCP client program. We start by creating a client socket again. We connect it to an address once more. So we're going to use port 80 because that's the port that most web servers run on. But we specify it the exact same way we have been doing before. And the last line is what ends up being different. So we're going to call the new function that we've included from this header file. It's inet a to n. It looks like this. So this basically converts the string address that we have stored from the command line argument and converts it into a format for our address structure so we know how to connect to it properly. So the first parameter is our string address. That's the command line argument. And then the second argument is where to store the converted address. So we're going to pass a pointer essentially, or rather pass a reference to the place where we had been storing our addresses before, the structure inside of our address structure. Previously we used to place the inet any value there, but in this case we're going to pass a reference to it to this function, and it'll store the address of the converted IP that we pass in as a command line argument to this function. So remote address is our structure storing the address information, and the SIN-ADDR structure is a struct in which we store the real address information. And so we're passing it as a reference here to store the real address information from this function that will get converted from the IP that we pass to this program when we run it from the command line. So from there, like before, we connect. We call the connect function on our socket and connect it to the address that we specify, and that call looks exactly like bind. So we call connect. We connect our socket to the remote address. And then really quick, let's create two variables to hold a request and a response.